There's a specific moment in rat control that most people never get past. They set out traps, check them the next morning, and find them untouched. The bait is still there, nothing has been caught, and the assumption is usually that the traps are in the wrong place, or the bait isn't right, or they need something stronger. But in most cases, the problem isn't the trap at all. It's a behavior called neophobia, and once you understand it, the standard approach to rat control starts to look very different. In this video, we're going to walk through a real-world rat infestation in a chicken house, where two methods were tested side by side. One of them, the one most people talk about, caught nothing on the first night. The other produced heavy feeding results overnight. The difference comes down to one thing that most DIY guides skip over entirely, and it changes how you should be approaching rat problems on any property. Before getting into method specifics, it's worth being clear about what an active rat infestation is actually doing to a property while it goes untreated. Rats have continuously growing incisors. They can grow up to 4 to 5 inches per year if not worn down. To keep their teeth at a functional length, they must gnaw constantly. That means electrical wiring, insulation, ductwork, plumbing, wood framing, and even concrete are all fair targets. Gnawed wiring is a direct fire hazard and one of the leading causes of rodent-related structural fires. In agricultural settings like barns and chicken houses, the damage compounds quickly. Rats consume and contaminate significantly more feed than they actually eat. A large population can waste tons of feed annually. They kill chicks, eat eggs, and spread pathogens, including Salmonella and E. coli, directly to poultry flocks and their feed and water supplies. Beyond property damage, rats are documented vectors for over 35 diseases transmissible to humans and livestock. These include leptospirosis, spread through urine-contaminated water and soil, hantavirus, which becomes airborne when nesting material or droppings are disturbed, salmonellosis from fecal contamination of food surfaces, and rat bite fever from direct contact with saliva or scratches. These aren't rare edge cases. They're consistent risks wherever active rat populations exist indoors or in close proximity to people and animals. The reproduction rate compounds all of this. A single female rat can produce 5 to 10 litters per year with 6 to 12 pups per litter. Under favorable conditions, shelter, food, water, a small population becomes a large one within a few months. Quick knockdown is not just preferable, it's the only approach that actually gets ahead of the population curve. Neophobia is the instinctive wariness rats show toward any new object introduced into their environment. It's an evolved survival response. In the wild, a novel object could be a predator, a trap, or a poisoned food source. So rats observe new things from a distance, test them cautiously, and often avoid them entirely for days or weeks before accepting them as part of the environment. Norway rats, the most common burrowing species, are strongly neophobic. In a stable environment like a barn or home with established foraging routes, introducing a new trap or bait station can trigger this avoidance response and render the device useless for an extended period. This is the direct explanation for why a trap baited with peanut butter placed in a visibly active area can sit untouched for days. It's not the bait. It's that the object itself is new and the rats are not yet comfortable with it. The degree of neophobia also varies with food availability. In an environment where rats have abundant competing food, like a chicken house with open feed, the motivation to investigate something new and unfamiliar is much lower. When rats aren't hungry, their threshold for risk-taking drops significantly, and new objects get ignored even longer. The demonstration that illustrates this most clearly involved a heavily infested chicken house with rub marks, the greasy trails left by rat fur along frequently traveled edges and entry points, droppings throughout, and clearly active population movement. The challenge was compounded by the presence of chickens and their feed, which provided constant food competition for any bait placed. Two methods were set up simultaneously in the same space. Method 1. The Vulcan Multi-Catch Bucket Trap. The Vulcan is a well-engineered multi-catch trap that converts a standard 5-gallon bucket into a self-resetting capture system. Rats climb a ramp toward bait placed on a tilting plank. When their weight shifts the plank, they fall into the bucket below and the mechanism resets automatically. The manufacturer claims capacity for up to 30 rodents, and independent testing in lower competition environments has demonstrated multiple catches per night. It was baited with a professional-grade rat lure and placed along an active runway near clear signs of activity. The next morning, 0 rats. Nothing had entered. This wasn't a failure of the trap's design. It was a predictable outcome of neophobia combined with competing food. The Vulcan is a novel object. Rats in an environment with abundant chicken feed had no compelling reason to investigate an unfamiliar structure, and their neophobic instincts kept them away. Method 2. Tamper-resistant bait stations with soft bait. The second setup used enclosed lockable bait stations. The type designed with entry holes, sized for rats, internal rods to secure bait, and locking lids that prevent access by non-target animals including chickens, dogs, and cats. Inside the stations, soft bait. Specifically, a product called Contract Soft Bait, which is a bromidolone-based single-feed anticoagulant in a pliable, oil-rich formulation. A more affordable alternative with similar palatability is First Strike Soft Bait, which uses diphethiolone as its active ingredient. The stations were placed along walls with entry holes positioned flush against the surface, the same principle as trap placement along rodent runways. Rats already familiar with traveling along walls and investigating enclosed spaces encounter the station as part of their normal movement rather than as a distinct new object to be evaluated. The next morning, heavy feeding. Bait was significantly consumed, scattered, and pulled from the holders. The stations had been heavily worked overnight. The result comes down to 2 factors that operated simultaneously. First, the stations themselves are low neophobia objects. Rats in barns and homes are already accustomed to navigating enclosed spaces, gaps behind walls, spaces under appliances, corners behind equipment. An enclosed bait station with an entry hole reads as a familiar type of space rather than a novel foreign object. Acceptance is faster and more reliable than with a new mechanical trap structure. Second, soft bait has significantly higher palatability than block bait in environments where competing food is present. Standard block baits use a paraffin wax base, which reduces their appeal when the rats have access to something more flavorful like grain-based chicken feed. Soft bait formulations are built around food-grade oils and fats without the wax component, making them considerably more attractive than the surrounding food competition. In high-competition settings, this palatability difference directly determines whether rats eat the bait at all. The anticoagulant mechanism, bromadiolone or diphethiolone depending on the product, works through the same principle as the boric acid bait discussed for other pests. It's slow-acting. Rats don't die immediately after feeding, so they continue behaving normally, return to the station, and often share food back at the nest, extending the effect through the population. Death typically occurs 3 to 7 days after the first lethal feeding, underground or within harborage areas, which reduces the number of carcasses in open areas. The Vulcan trap's failure in that initial overnight test doesn't mean the tool is ineffective. It means it was deployed without addressing neophobia first, which is true of most traps when placed into active rat environments. The correct approach is a process called pre-baiting, sometimes referred to as the switcheroo technique. Before activating the trap mechanism, lock the tilting plank in place so that it can't trigger. Load the bait compartment generously and place the trap in its intended position along a wall or runway. Leave it there, locked, for a minimum of 3 days, and often up to 2 weeks for Norway rats in heavily established environments. Refresh the bait daily. During this period, rats approach and feed from the station because it poses no risk. Juveniles typically enter first. Adults observe and follow once the younger animals have established that the object is safe. Feeding patterns tell you when acceptance has occurred. You'll see consistent bait consumption over several days. Once rats are feeding from the station routinely, remove the locking pin to activate the tilting mechanism. Rebait and leave it. At that point, catch rates climb substantially because the population is no longer avoiding the object. They're actively seeking it out. Used this way, the Vulcan functions as a high-capacity, non-toxic option that can clear significant populations in lower competition or preconditioned settings. It's most effective after soft bait stations have reduced the overall population, or in environments without strong food competition like unused outbuildings and garages. Regardless of which method you're using, placement follows the same underlying rule. Rats travel along walls and edges rather than crossing open floor space. This behavior, called thigmotaxis, is a predator avoidance response. Staying in contact with a surface means immediate cover is available if a threat appears. Rats also have relatively poor eyesight in open, lit spaces and navigate primarily through their whiskers and spatial memory of established routes. Every trap, station, and bait placement should be flush against a wall in a corner along the base of a structure or directly on an identified runway. The entry holes of bait stations should face the wall or corner. Multiple placements in series along active runways outperform single placements in terms of encounter rate. Identification of active runways requires inspection first. Look for rub marks, the dark, greasy smears left by rat fur on surfaces the animals contact regularly. These are reliable indicators of consistent travel paths and are typically found along the base of walls, around entry holes, and at corners. Fresh droppings also indicate high activity zones. Place your control methods where the evidence is, not where access is most convenient. The bait station demonstration covers the knockdown phase, reducing the active population quickly. But bait stations alone are not a complete rat control program. For the same reason that any single method is insufficient, they address the current population without addressing what's sustaining it or preventing new animals from entering. Sanitation removes the resources that allow the population to sustain itself. In a chicken house context, this means securing feed in metal containers rather than open bags, cleaning up spilled grain promptly, managing water sources, and removing debris and clutter that serves as harborage. In a home context, it means secured food storage, sealed trash, no standing water, and eliminating the ground-level cover that rats use to travel between harborage and food. Sanitation also directly improves bait performance. Rats with abundant food sources are less motivated to feed from bait stations, reduce the competition, and consumption rates increase. Exclusion prevents reinfestation after the active population has been reduced. Rats can enter through a gap as small as half an inch. Common entry points include gaps around pipe penetrations through foundations and walls, damaged soffits and fascia, gaps under doors without sweeps, spaces around utility conduits, and cracks in foundation walls. These should be sealed with materials rats cannot chew through: steel wool combined with caulk or foam, hardware cloth with quarter-inch mesh, metal flashing, or concrete. One important sequencing note on exclusion. In heavy infestations, seal entry points after the population has been reduced, not before. Sealing while a large population is still active can force rats into the interior of the structure looking for exit points, creating more damage and potentially driving them into areas where they weren't previously active. Monitoring should continue after the initial knockdown. Use sticky traps or non-toxic monitoring bait blocks in stations to track whether activity has actually ceased. Measure catches per week or bait consumption over time and watch for new rub marks or droppings. A population that appears eliminated can rebound quickly from egg cases that hadn't yet hatched, from juveniles too small to have been caught initially, or from new animals entering through exclusion gaps that weren't fully sealed. The question that comes up most often with anticoagulant baits in environments with pets or livestock is secondary poisoning, the risk that an animal eats a dead or dying rat and ingests the anticoagulant indirectly. With second-generation anticoagulants like bromadiolone and difethialone used in soft bait formulations, the risk exists but is low when bait is used in secure stations and carcasses are removed promptly. A pet would need to consume a large number of dead rats to accumulate a dangerous dose from secondary exposure alone. That said, the risk is not zero, and in environments with raptors, owls, and hawks that may prey on poisoned rats, the concern is more significant. The practical approach is to place all bait strictly within locked, tamper-resistant stations. Check stations regularly so you're aware of consumption levels, remove any dead rodents you find promptly using gloves, and dispose of them in sealed bags. If a pet does access bait or a carcass and you have any concern about exposure, the antidote for anticoagulant poisoning is vitamin K1. Contact a veterinarian immediately. For properties where chemical bait is not appropriate, the Vulcan trap with full pre-baiting and placement along identified runways provides a non-toxic alternative that can achieve meaningful population reduction with consistent management. One final point that's often overlooked: how you clean up after an active infestation matters for your health. Rat droppings, urine, and nesting material are potential sources of hantavirus and leptospirosis. Do not sweep or vacuum dry droppings. This aerosolizes particles and creates an inhalation risk. Instead, wet the area thoroughly with a disinfectant solution first, let it soak for several minutes, then wipe it up with disposable gloves and paper towels. Seal everything in plastic bags before disposal. Wear an N95 mask and gloves during any cleanup of a heavily infested area. To summarize the core finding from this comparison, in a real-world, high-pressure infestation with competing food sources, tamper-resistant bait stations loaded with soft bait outperformed a multi-catch mechanical trap by a significant margin on the first night. The reason is not that one tool is inherently better, it's that soft bait stations work with rat behavior rather than against it. They present a familiar object type, offer a more palatable bait than the competition, and require no overcoming of neophobia before they start producing results. The full program: soft bait stations for knockdown, pre-baited mechanical traps as a non-toxic complement, sanitation to reduce competing resources, and exclusion to prevent re-entry, covers every phase of the problem. Each element addresses something the others don't. Applied together and followed through consistently, this is what actually resolves a rat infestation rather than just temporarily reducing it. If you found this useful, subscribe for more practical, research-based pest control content. We'll see you in the next video.